Sir, good morning, sir. Sorry, sir. Sir, join பண்றாங்களா சார்?
குட் மார்னிங் சார். ஜாயின் பண்ணுவாங்க சார் இப்போ.
ஆக்சுவலா லைவ் போயிட்டு இருக்கு சார். லைவ் ஸ்டார்ட் ஆயிடுச்சு சார்.
அதான் ஜாயின் பண்ற சொல்றேன் சார்.
குட் மார்னிங் சார். ஹெச்ஓடி சார்.
Good morning, Rajin Pal sir.
Good morning.
Good morning, sir. Nachiappan Palaniappan sir. Good morning.
Hello. Hi.
Good morning, sir.
Good morning, sir.
How are you all?
Proceed, sir. Prasad, sir. Shall we proceed, sir?
Yes, sir. Sure, sir. We can proceed, sir.
Proceed, sir.
Yeah, just 1 minute. I'm just putting up my slides.
Yeah. So just a minute, sir. Before that start, then after that you can take over the sessions. Good morning to everyone. A warm welcome to all the participants joining us on RMKCET YouTube live stream. I am Dr. Prasad R, Professor, CSE Department of RMK College of Engineering and Technology, and I am delighted to be your host for today's session. At the outset, I express our sincere gratitude to the RMK Group of Institutions Management for their constant vision and support in organizing such valuable platforms. We also thank our respected principal for the inspiring leadership and our heads of all the departments for their wholehearted coordination and encouragement in making this event a success. It is my pleasure to welcome you all for the 47th edition of Generic Talk series, proudly presented by RMK College of Engineering and Technology, an autonomous institution under RMK Group of Institution. Now, I invite our respected Head of the Department of Computer Science and Engineering, Dr. R. Rajaguru, sir, to share the inaugural speech. Over to you, sir.
Thank you, sir. Beyond the prompt, thinking, building, and working in AI era. Good morning to everyone. Respected Mr. Nachiappan Palaniappan, Director of Analytics, Nykaa, Gurgaon. Respected Principal Sirs, Dean Academics and Dean Research, distinguished faculty members, and my dear students. It is my privilege and pleasure to welcome you all to the Generic Talk Series 47 organized by the Department of Computer Science Engineering in RMK College of Engineering and Technology. We are indeed too honored to have with us today Mr. Nachiappan Palaniappan, an accomplished professional and an industry leader in analytics. Sir, we are delighted to have you with us and we are sincerely thank you for accepting our invitation to share your valuable knowledge, experience, and industry perspective with our academic community. So, the theme of today's sessions, Beyond the Prompt, Thinking, Building, Working in the AI Era, is both timely and highly significant. We, we are witnessing a fundamental transformation in the way of technology in shaping and professional and personal artificial intelligence has moved beyond being merely a technological advancement. It has become a strategic enabler of innovations, productivity, decision making, and business transformation. In this rapidly evolving environment, simply knowing how to use AI tool is no longer sufficient. The real differentiate will be our ability to think critically, ask the right question, understand the problem, building the intelligent solution, validate the outcomes, and use AI responsibly and ethically. For our students, this transition presents both an opportunity and responsibility. The professionals of tomorrow must not simply become user of AI, they must become a problem solver, innovator, creator, and responsible technological leaders. As an institution committed to the developing industry ready and future ready graduates, sessions of this nature play a vital role in bridging the gap between academic learning and industry expectation. I am confident that today's interactions on will provide our students with valuable insights into an emerging technology, workplace transformation, industry requirements, and competences they need to develop for a successful career in AI era. I encourage all our students to make most of this opportunity not merely by listening to the session but by actively reflecting on the ideas shared, asking meaningful questions, and thinking about how they can apply the insights to their own learning, project, research, and career. Once again, on behalf of RMK College of Engineering and Technology and the RMK group of our institution, extended our warm welcome to the today's resource person, Mr. Nachiappan Palaniappan, for being with us today. I wish the session a great and successful and hope that is inspire our students to think beyond the boundaries and work confidently in the AI era. With these words, I warmly welcome you all to the Generic Talk Series 47. Thank you. Have a wonderful and insightful session. Thank you, sir.
Thank you, sir. Today's talk is titled Beyond the Prompt, Thinking, Building, and Working in the AI Era. The topic that is incredibly relevant and essential in today's AI powered world. Whether you are a student, faculty, or professional, today's session promises to offer insight that will truly shape your understanding of artificial intelligence. Now it's time to introduce our distinguished speaker for today's session. Nachiappan Palaniappan is an analytics and AI leader with 15 years of experience across e-commerce, data science, and technology, spanning Nykaa, Amazon, Flipkart, and Latent View Analytics. At Nykaa, he leads a 25-member analytics team working at the intersection of AI, data, product, and business decision making. His recent work centers on building agentic AI systems that reason over complex business problems, systems that do not just surface what changed but explain why and hold themselves accountable for the answer. Having worked through every generation of analytics, from traditional BI and machine learning to generative AI and autonomous agents, Nachiappan brings a builder's view of where AI genuinely creates value, where it quietly fails, and why design matters more, not less, in an AI first world. Once again, I welcome Mr. Nachiappan Palaniappan, sir. Let us give a warm virtual welcome to him. Over to you, sir. Thank you.
Thank you so much, sir. Yeah. So before I begin, I would like to extend my gratitude towards RMKCET for facilitating this talk. Always, it's been a pleasure. Like whenever I interact with students, and I would love to do that. Like at any point in time. So I see this as a mutual learning. So I also get to learn a lot about the recent trends and all those things from the students. At the same time, I wish to exchange my ideas. So in that way, it will be an enriching platform for both of us. That's what I believe. And yeah, truly thankful to all the faculties who have arranged this. Like, I'm sure like you guys must be working around the clock in facilitating this. And I see this is the 47th episode of the series, and it is no joke. So doing this consistently matters more, and like it helps the students to uh, gather like knowledge from wide variety of people. So that I mean, like first kudos to you all in organizing such. Periodical episodes like this. Like I'm truly thankful to you all for that, and also my gratitude towards the students on a Sunday morning. People are here. I mean that is actually a great thing. Like, and I see this to be a tectonic shift from my times. Like when I used to be a student, I know like after the 5 p.m. bell rings on Friday, that's it. Like the next thing that I ever think about college outside of the friends is like around 10 a.m. on a Monday morning. So, but I could actually see the enthusiasm and the improved attention and like focus towards like how they should be better adapted to the changing environments or rapidly changing environments, right? So in that way, like I'm super truly humbled by the students' commitment. Thank you all for that. And yes, I do have like a lot of slides today, but I would like to keep it more open-ended, like more like a discussion kind of thing rather than sticking to the slides and being a monologue. So please stop me from wherever it is. I'm not sure like how do I get to see the students' comments, but Prasad sir and Rajaguru sir, like it will be great if you could help me with like if there are any questions, please post it here. I would like to take that like then and there. And towards the end, also, we have a broader Q&A session. So you guys can ask questions. Like, obviously, whatever I know, like, I'll be super great in sharing my knowledge. Yeah. With that said, I would like to share my screen. Uh, I need to enable. I might have to rejoin. Sorry about that. Like, not to share my screen, I need to give certain permissions.
Okay, okay.
Yeah, sure. I hope my screen is visible, right?
Yeah, yeah, yes, sir. It's visible.
Okay, great. So yeah, the topic for today is uh, thinking beyond the prompt, thinking, building, and working in the AI era. This is one landscape like which is changing almost every 3 months. Like whatever used to be the norm 3 months ago is not a norm anymore. So I believe like a constant refresh of this particular thing would be super helpful. And I've tried my level best in like keeping it up to the speed and like segregating the fundamentals separately, which doesn't change, and also enrich it with some of the uh, other context contextual stuffs that we need to be aware of in the current world. So before moving into there, obviously when it comes to AI, like people generally ask, are you AI native or are you AI familiar? So there is a clear distinction between these two. AI native is people like, or I'll probably start off with the AI familiar. AI familiar is people know, okay, I have been using ChatGPT or Claude or DeepSeek or Gemini, like for whatever it is, right? So if you use for your if you prompt and then like get that response and all those things, uh, that might sound as AI familiar. That might sound as AI native, but it is just AI familiar. AI native is you working alongside AI. You're able to think, build, and execute using AI. So that is what we define it as AI native. Yeah, and then yeah. So would like to spend about a minute in defining like what are these individual components and what we will be covering into each of these three sections that we have, right? Thinking with AI. So this is more like how to define a problem, what is AI and what not is AI, and what it can actually do. Like what are the common known pitfalls in building the AI based system. So how to think differently in the AI powered environment. That is what we will be covering in the think section of it. And building it, how to build it along, how to leverage AI capabilities and build your systems, right? Rather than just asking it, okay, hey, can you please build XYZ, right? Like what are the fundamental differences in the traditional way of building the apps versus like building it with AI. So that is what we will be covering here. And third section, that is, I believe that would garner most of your interest, like in the working with AI era, like what happens here, like uh, does AI replace humans and all those things? You have answers for all those questions here. Yeah. Yeah. Any questions, anyone so far?
No, sir. No, sir. You can carry on.
I think thinking with AI, right? So when ChatGPT was introduced in November 2022, I believe. So at that time, right, like, so we were all fascinated about like when we prompted, okay, hey, how do you write a code for this? How do you write a query for this particular use case? It gave an answer, and then we were all super enthusiastic. And then like it came a field called prompt engineering. That was a uh, separate field by itself, like where how to get the right answers by prompting it differently and all those things. So uh, there was a separate field that emerged. It was super popular in 2023, 2024, and then it eventually died down now, right? Like it is still an art, but it is not the core skill anymore. So knowing how to prompt alone would not be sufficient. Knowing what you really want is the key thing that is required, right? So think with AI and it should not be through it. Like, so given a problem statement, you should have a clear vision of what you need to build. And like you should not like ask the open-ended question to AI, okay, so how can I build? Right. So before we dwell deep into the thinking with AI, I would like to give a brief of history about like what is AI and what not and all those things. So AI might be trending in the last 2, 3 years. More like almost every organization or every LinkedIn profile carries some element of AI, right? But this term or this terminology has been existing from 1956 from a forum. In fact, like the actual work began in 1950 and it got presented in a 1956 conference. Uh, that is when the AI as a term gets coined. And then in 2000s with the with the on like popularity of computers and all those things, like there evolved a lot of algorithms and stuffs. Like between 2000 and 2015, we have mastered the art of writing like the hardcore algorithms, and then like we went into the machine learning. So I think like late 2010s or like early 2011 12 types, that's when AI and analytics as a field started emerging. And thankfully I did my graduation around that time, and I was lucky enough to be part of that tide. uh, and 2017 is a breakthrough year that is now the foundation for all the modern AI concepts that we are discussing, which is the transformer architecture. So, if you guys have time, please go through a paper called "Attention is all what you need" type. So that paper was the fundamental reason, or like that changed the game in which the LLMs were made possible, right? The transformer architecture, that's the powerful thing. So I'll give a brief gist about like what it specifically does, like and how it transformed, right? So. I would, yeah, I would like to go to this slide. So what are LLMs, right? Like LLMs are the ones like which is powering your chat GPT and all those things. You have like so many models, right? Opus, Sonnet, GPT-4, all those things. But all of these are large language models. What it does is it predicts the next sequence from the given the context. Okay, so the cat sat on the floor, mat or chair, moon, right? Like while everything might be relevant, mat is much more closer to the context. So this context based next sequence prediction is what LLM does. Given that it understands the context and it is able to predict the next word, it can understand any kind of context that you give, any so be it biotech or be it computer science or whatever be it, right? It can understand stuffs. It can uh, predict the word like which is going to come, or predict the sequence of words which is going to come next. Okay. Or if you ask a question, like if you ask it to write about say global warming, it can write essay about global warming, right? That is primarily because it has contextual knowledge trained globally. So there are billions and billions of records which were used to train these models, which is humanly impossible to do it on any single system. So there were a lot of high scale systems that were deployed to train these models. And finally, what we have is those LLM models that is powering. Given that, so the context-based understanding is the key difference between the LLMs and the historical um, sequence predictions, right? So, uh, if you guys would remember, back in 2015-16, there there was next word predictor in our Android phones. Like whenever you used to type a message, that used to be a next word, right? But the next word would be relevant based on the prior, say, 3 4 words. It will not have the context of like what you're essentially writing, right? Like the entire document, it may not be able to parse all those things. So there were like numerous concepts like LSTM and all those reinforcement learning, everything like was there in the picture. But the transformer architecture, like with the contextual knowledge, that transformed. And then we got ChatGPT in 2022, and the rest is history that you guys are better aware than what I could actually say, right? And this language is a fundamental of human evolution as well, right? When we defined more fluent language about 70,000 years back, that's when the growth rate of human evolution was also like pretty faster. So when you understand a language more deeper, you will be able to absorb the thoughts better, not just understand, but absorbing the thoughts. That's where the clear distinction comes in. And then you will be able to transfer the knowledge and reason against why this is true, why it cannot be true, and more like a debate kind of a thing. So these are the three core elements which led to the human evolution, and same thing happening here, with the fundamental difference being humans add the power of reasoning or validating, right? And here you need to code the system to validate or reason it in the way you think that is right. And once that is done, all the facts that you are getting, you will compare it against the set of rubrics that you have. And then if it matches, else you throw it against. So the system is as good as how you define, right? AI does not comes with the inbuilt knowledge, while it has like some knowledge from the training data, but it cannot understand like how your system should work. That is where your definition matters the most, right? So the definition is extremely important in whatever application that you're defining, right? So let's probably take an example, right? Like I'll take one example which is technical, as well as one example which is not technical, right? So just to keep the session interesting, right? So since a user, I'm using ChatGPT as a client, or like Cloud as a client, and I'm like trying to define a bike for my own use case. Okay, I am asking it to build a model for the bike. If my prompt is gonna be okay, hey, I need to travel from point A to point B using a bike, I need to define it, right? So it can either give me a KTM, or it can give me a Activa, or it can give me a TVS 50 or whatever, right? I need to be very specific in what I want. All of them are like the bike which transports people from point A to point B. So how do I define the suspension? How do I define the braking? How do I define the appearance of it, the speed of it, 0 to 100 in how many seconds? I need to define all those things so that the power of the bike, everything gets designed appropriately. So the definition matters the most here, right? Or else like it's as good as you uh, asking your prompt engineer, okay, I need to direct a movie, give me a love story for it, right? Like it can give you any kind of a movie, like happy endings, like or sad ending or whatever it is, right? It's up to you how you define it, right? So the definition becomes very clear, it becomes very essential. You need to have a vision of how your end product should look like. Okay, these are all the functionalities that is required, and the functionalities of individual component should match when they are put together at once. Say a shock absorber of certain uh, requirements or specifications should match with the wheelbase and all those things, right? So that is a key thing, like how a system should, how each component should be functioning and how it should function as a system. That definition has to be clear in mind before you even begin to execute. And then you let AI execute the code that, so, okay, now define these building blocks separately, and then you evaluate whether the given specifications is meeting the requirements or not. Like if it meets, great. If it doesn't, like repeat. So it's the same cycle that gets repeated every now and then, right? So once again, I would like to reiterate. So I'm sorry. If we want to build an attendance system, that's the requirement. Okay. So building an prompting any of the AI chatbots with a building and build an AI attendance system. It's just a mere wish. It's not really the uh, system that you're defining. So you need to enrich it with, okay, hey, I have a currently I have a manual attendance like which gets logged in a specific format, and this is the structure of it. I want to translate that into an automated AI system. Like that is like more like a defining the problem, how you want, what you want, and how the end output should be. And then comes the defining definition of architecture. Okay. Um, okay, a leave after like say X days of the semester holidays or study holidays should be counted as like what and all those things. Like those are the rules. Okay, like define some exception. Okay, if there is a sick leave and all those things, like don't consider them. So these are some of the inputs, exceptions, rules that you define how like the system should process it, and it gets refined. So this we call it as say building the system in loop, right? And evaluate your system whether it does the mechanism in the same way you're defining. If it doesn't, then you repeat it. So we generally call it as loop engineering. So we generally build it in iterations, right? What also matters is when to use AI and when not to use AI, right? So given that AI is a fancy thing, people are all like embedding AI calls, AI API calls in everything that they are building. So one, it is bad in two ways. One, uh, of course, every uh, prompt is involves like input tokens and output tokens, and each token costs you some dollars. So it is an expensive affair. And second thing is sometimes we have to be deterministic, not probabilistic. AI gives you a probabilistic output and not the deterministic output, right? The difference between these two is, right, when I when I know, like, okay, say for example, if attendance is greater than 75, then it's great. Okay, like it's a green signal. Okay, I'm filtering all the students who are meeting this. Else it is fast. That I don't have to be probabilistic here. What probabilistic means here is, okay, what is the probability that this candidate meets the attendance bar, right? I know, like, I have the attendance system at the back end, like of 100 days, like how many days he is present and he is not. So I can say it more deterministically. I don't have to be probabilistic here. So those kind of nuances is something that we need to understand. Where we need to be deterministic, we have to be deterministic. Where we have to be probabilistic, we can leverage AI or ML there. So having this knowledge also helps in building the robust system, which is one, works in an intended way, and two, is less expensive, right? And the second failure thing that often comes is, right, we stop checking what is something that we are getting. Let's say I am writing a query, right? Like, so to get the number of orders that has happened yesterday, right? Here the order data can be present in multiple system in a production environment, while there is a central fact table where it maintains all the order history, order books, right? There can be other places like other reports where we use orders. Say there is a clickstream event and all those things where the orders gets captured, but that may not be the right source of orders. So whether this AI had written query using your primary source or the other source, right? And whether the aggregation is done right and all those things. Checking the facts is more essential. And second thing is, right, that is something we call it as rubric-based evaluation, which is how the flow should be. Okay. If I'm asking a question like, okay, why did my orders drop and all those things? What are the sequence of events that should happen, and what output I should get from each of those stage, whether uh, based on the output of the previous stage, whether the right set of the next steps is called or not. So the checking the flow of events and the flow of thoughts, that is also more important. So unless our evaluation or observability is right in place, there can also be another failure mode where your AI can hallucinate a lot, right? So this is exactly what we what we uh, defined, all right? So, so I would like to spend time here as a next thing. So the way to think about building an AI system is you need to have observability, orientation, deciding, and act. This is a proper four-step framework that the US Army team generally uses it. So observe, gather all the signals that is out there, and then orient, like for this context, like what are required, what is not required, which tools to use, and all those things. Decide what is the trade-off, like should we even do it or not? Should we invoke this call or not? And all those things decide, and then execute. So make sure when you're thinking of the AI system, it is following this four-step protocol, right? Are there any questions so far?
No, sir. No, sir.
And one thing that I would like to call out before we move on to the next step, which is building with AI, is the common problem that AIs are often attributed to, which is hallucination. AIs can hallucinate, and the consistencies, right? So that these are the two other uh, general pitfalls that you everyone should be aware of, right? Why hallucinations even happen in the AI world, right? Like I know these two concepts you guys must be hearing a lot, or like must have heard a lot, right? And it is not new, but did we ever understood why the AI models hallucinate? Because as I said, it is more on the context-based prediction, right? So what if the context changes a bit here and there? Then the entire prediction can be wrong. I would like to quote some examples that from the real world. There has been like couple of widespread incidents that has happened in 2023 and later in 2024, I believe. Yeah, in 2023, what happened is a set of lawyers presented a case in the U.S. court. Right, it was like shared like globally, presented a case in US court citing the uh, judgment examples for different case where the judgment was done in certain way. But turned out to be all those examples that has been quoted by the lawyers are machine generated and not the actual ones. Right. This was the one of the hallucinated or system generated responses, right? Like it can actually build the context and it can present it confidently. You will not even have a doubt that okay, whether it is actually doing the right thing or not. I believe you guys must have seen the recent movie. In one of the movies, like where a tutor asks the student to go and solve a particular problem on the board. He goes and solve it confidently and comes back and sit on the desk. But turns out to be like he must have written the same question again and again, and with the ending note of hence proved, right? So AI is capable of doing that until it is guided properly and like trained in a very uh, defined manner, like we call it as AI harness. Like it has to be enriched with a lot of context, and it has to be given like what it should do, what it should not do, and all those things before like set very clearly before we build any example. So hallucinations differs from the context and consistency. The same prompt that you type in ChatGPT or Cloud versus somebody else typing, they both might not have the same responses back from the system, even from the same systems, or even for the same user, for the same question asked at two different point in time, you will not be guaranteed in getting the same responses. So that is another thing. So how do you ensure the consistency and the hallucinations? How do you ensure the consistency is preserved and does not the system does not hallucinate? That is an important part of building any system which is powered by AI, right? So as I conclude the first part, the thinking with I would like to reiterate the philosophy. Define the system before AI even touches it, and evaluate the system after every AI touch point. So that is more essential. Now moving on to building with AI, right? So building with AI. So here is the fundamental nuance that people are understanding now. Like I wouldn't say it is a widespread understanding that existed even in 2025, which is the ownership and accountability lies with the person who is building it, right? This is a key difference which transformed the way we have built the system in 24-25 versus now, right? We will see the examples like as we go through the slide, how we have changed the building or like philosophy, right? So AI system and all the code generators can execute, but it cannot understand or architect a system on its own. yet, right? So you can delegate the execution, but never delegate the understanding. So what happens is, right? So I would like to put the industry-wide thing that has happened, like say early 2025. So there was a term which was like very popular. I'm sure you guys must have heard vibe coding. What happened is, just to give you some context, typically there is a component that is being that will be discussed in every annual operating meeting. So which is operational plan meeting, which is tech debt. Tech debt is like typically we want to build systems and products which involves, let's say, which should ideally take 100 developer bandwidth, but we might be just having 50 to 60 developers in the system. So always the tech debt used to be 50 to 60% for any established organization. So we will always have 1.5 to 2x of workload for every resource that we have, right? And when AI came, like we wanted to improve the productivity and delegate the execution to AI. And and we thought like, okay, this will reduce the tech debt by at least 20-30%. So the tech debt from 50-60 can come down to 30-40, or at least 25-30%, right? But what came as a surprising is, in fact, the tech debt increases. Here is why it happened. Because what happened is people like even let's say for example you're searching in a Swiggy app or a Zomato app for a particular dish. Okay, there is a whole lot of product and what needs to be shown for which user. There is a bunch of algorithm that executes at the same time at and renders response in like hardly 1 to 2 seconds, right? So there is a lot of concurrency that needs to be ensured, like a lot of algorithms like which should be aware of inventory and your ML, like which is personalized to the user who is searching for it. So there are a bunch of algorithms that is there in place. So what if I ask the AI to code, okay, hey, I need to scan my inventory and identify the list of menu items which is closer to the user query. Let's say if I have searched for uh, say burritos. Okay, what are the burrito options that I have in my inventory list? And the second service which runs, okay, find the restaurants which has burrito like in the closer proximity of the correct user. And the third, okay, service which identifies like what are the famous restaurant for this particular user, right? Where where this user has ordered before. And the fourth service which can run, okay, what are the restaurants which are offering the good pricing deals today for burritos? So there can be n number of services which is happening. And for each of the services, I've defined AI system to write a code. Okay, you need to write a code for the personalized recommendation. You need to write a code for the better pricing. So AI had written all those like codes, and when we orchestrate, it didn't work. There was a failure. And when it fails, the developer, neither the developer nor the product manager had any clue on where to fix it, because all the lines of codes were written by AI. And obviously not all the boundary conditions has been tested. So even if one boundary condition fails, you have to uh, make the necessary changes and release the product update, right? And when the developer, they themselves didn't know like where to change and what to change, it led to the productivity, sorry, it led to the uh, time increase that a developer ideally would have taken if he had written it from the scratch. So that's when the vibe coding as a concept without uh, accountability and ownership failed. So we then like we then move forward. Okay, so we'll define each block and we'll provide context. We will write the uh, do's and don'ts, and then like we execute the micro task through AI. Okay, hey, I need a authentication service. Okay, give me authentication code. It gives. And then so I will engineer like each and every component separately as a micro task, and then orchestrate it like as a whole system. And the way to orchestrate also has been defined by the user, and AI executes it. So what happens now is like now I know, okay, which module contains what kind of a coding logic, and I will be able to validate that output. Like I can unit test it now, and I can have a very deterministic output out of each of the micro task or micro modules that is out there. Right. So one key skill that is relevant in the past, that is relevant now, and that will be relevant in the future, which is the system design, right? How a system should be designed for any particular need. Okay. As I said, like when there is a Swiggy app, it extends as a API gateway to all the front-facing clients. And then when a user orders, the order gets processed and it is sent to like multiple uh, modules out there, like payment and then the corresponding kitchen and then like the dispatch service where the delivery executives are there. So now the dispatch service should talk to kitchen and whether the order is ready and can be picked up, and then the kitchen in turn like coordinates with the payment and all those things, whether the payment has been made and the order is successful and all those things. Once that is done, the all three has to notify the system, okay, yeah, what is the status and all those things. So this is how you define the system. So system design is a key parameter, like which is relevant across uh, all the age. It was relevant in the past, in the Stone Age, as well as now, right? And for this kind of a, say Swiggy or Zomato kind of a, or food commerce or any e-commerce ecosystem, right? So where are the places where we can use AI, ML, and like say where it has to be fully agentic support, agentic AI powered, right? The for the payment gateways, it has to be extremely predictable. Sorry, extremely deterministic. There is no room for predictability here. So in this particular component, there has to be no AI. It has to be only logic powered. You can leverage AI to write the logic, but you cannot use AI in real time, like for any payment processing, right? So this is strictly no AI. ETA, like which is like I ordered something in from some kitchen, right? When it is expected to arrive. This is expected time of arrival. So this can be an ML problem. You need not have AI here, but it can be an ML problem. You may or may not have AI here, right? So, but it can be done through traditional ML platforms. Okay, uh, by this time the order should have been picked. If it is picked and like the distance between the point A, the restaurant, and the customer location is Y kilometers, and typically it takes Z minutes to reach this on a Monday morning 11 o'clock types. So you can have a predictable system. Okay, it is predicted that the food will be delivered in 23 minutes. You cannot be very deterministic. You cannot be very sure of this 23 minutes ETA. You can be say 90% of the times the food gets delivered in 23 minutes. So this is a prediction problem and not really a deterministic time. What is deterministic is like, okay, what is the quantity that I need to give? That is deterministic. That there is no predictability here. So whatever is definitive, those are the places where there is no room for AI. Wherever we can predict, see if it can be done through ML, the traditional ML algorithms, or else use go for the AI. And ranking. So which restaurant to show, like where, like first, and like what should be shown second. So the relevance and ranking is a key algorithm that any e-commerce apps you use, right? So when you search for something like in say in a Myntra app or an Amazon and all those things, what should be shown for each user is determined by the algorithms, right? That is, those are ML. And the ranked list of items that you get to see are probabilistic in nature. Okay, there is a high probability that a customer might order the first one, and slightly lesser probability to order the second, third, fourth, and so on and so forth. Once again, this is also probabilistic in nature. So use of AI or ML is much more pronounced here. And the fraud detection. Sometimes people place a lot of returns. How would you differentiate a legitimate return from a fraudulent return? Right? So once again, you can be probabilistic here. You cannot be very deterministic. Oh, this customer has written 7 out of 10 items. Then definitely he is a fraudulent customer. No, that can need not be the case. So sometimes the size must have not fit him well, or the item could be damaged. The reason can be anything. You can say, okay, he has written 7 out of 10 times. There are high chances that he can be a fraudulent customer. I cannot be like very sure of. Once again, this is also probabilistic. Hence it is AI or ML. And then the support, customer support. Okay, where is my order? These are some of the things which can be done through completely AI, right? And minimizes the human interaction. See, if I'm not wrong, Swiggy processes millions of transactions every day. And even if you assume 1 million transactions every day, and 10% of the orders have got a problem, and say of that, like 50-60%, they are raising a complaint. You need about 50,000 calls, and each call, like let's say it spans for about 12 minutes or something like that. Then it is about 6 lakh minutes that we are talking about, right? Which is roughly 10,000 hours. And if you divide 10 hours per executive, you require about 1,000 employees, right? For every 1 million orders, right? Which is a lot. Like a company might not have those many employees. So tomorrow, if my order history increases from 1 million to, let's say, 1.5 million, like there are like so many offers that's in place, I cannot scale the employees from 1,000 to 1,500 in a single day, right? So in that cases, having this AI system helps. Okay, so most of the queries are, okay, where is my order? Like if 50% of the queries are, where is my order? Like you just have to query different systems and then produce the contextual knowledge for the user. So then the 1,000 users requirement scales down to 500, like if there is an AI system. So those are the ways like in which AI can be deployed, and not everywhere. Yeah. And this is a classic use case. Sorry, can you please excuse me for a minute? This is a classic use case that we typically encounter in the business almost like every week or every month, right? Maybe not to this extent, but why did my revenue drop by 10% yesterday, 15% yesterday? And the reason can be plenty, right? So in a typical commerce kind of a setup, right, you have about 200 odd metrics and 40 odd dimensions. Net, you will have like about 1 lakh ways of representing the same problem, right? Like the reason can be anything. It can be you ran out of the stock of your top selling item, or your promotions must have ended, or your customers who come to the platform, it used to be like a lot of your loyal customers. Now the customers are like mostly new customers, or like the marketing customers. Say earlier, like 20% of the traffic comes through Instagram, and now like 50% comes through Instagram. So it can have some amount of conversion compared to the people like who are opening the app directly without any marketing push. So the reason can be plenty. So without any of this context, if you just ask the system, why did the orders drop 15% yesterday, right? It can give some random answer, and it can give random answers to different people for the same question in the same company. So that is when we give context to it. Okay, whenever a question of order drop that has come, okay, how would you answer the problem? Okay, so there are 6-7 components which can fail, which can lead to the order drop. And how it can lead to order drop is this, right? So you define the entire context, like what has happened in the past, like how do you deal with those situations, and what are some of the known gaps that is there in the system. So this is like enriching the system with more and more of your system's own context. This is context engineering. This forms the backbone of any AI system that we build. There is a popular saying, right? A system is as good as we build. the system is as good as we define here, right? So the context engineering forms the core foundational element of how you build the system. And then there is tools. Tools is like, okay, hey, I need to query XYZ things from the database. Okay, so I will write text to SQL as a tool, and uh, the scope of that particular tool is it translates a user query into the SQL and executes the SQL, returns the response of the SQL. Okay, if I want to know whether this order drop was just yesterday or like the last 1 week it has been dropping, okay, I need to hit the database, get the results. Okay, what does the uh, order trends for last 1 week, and how does that differ by different states and tiers of the country, and like in which region there is a problem, and all those things. All these are tool call to the databases where I execute the snippet written on the fly, and then I get the response back. Once I get the response, I have like response from multiple different tools. Now I need to write a code to process it. So writing the code can be another tool. Okay, it can generate the Python code to process the results from each of this tool, and then build a summary out of it. And then you need to render it as a presentable PDF. Translating that summary into PDF or into PPT, that can be another tool, or a dashboard. So dashboard builder can be another tool. These are tools which within each of those system, okay, you invoke to solve a particular problem, right? So there is context, there is tool. These are the building blocks of any AI system. And then you need to maintain a state, or like which we call it as memory. I know you guys must have heard about drag and all those things. So this is where it comes. So you need to know what one returns, like, and that needs to be passed on to as a context to the other. Let's say you evaluate, okay, why the order drop has happened. So let's say the order drop has come from Karnataka state in a particular pin code, like, okay, so it didn't happen. So that is one thing that is noted. And there is another reason, okay, hey, there is a payment gateway issue with respect to Axis Bank or like any other bank for that matter, right? Or UPI failure, like say there is some downtime with phone pay, right? As a result, there is a payment failure that has happened, and then the user checkouts are not resulting in order. So these two results should be passed into the third agent, which is like my customer. Like, okay, who are the kind of customers that is visiting, who are visiting my platform, whether it is a new customer, repeat customer. So it can actually interact with like different components of the system and then produce a cohesive output. So it's very important to maintain that memory. Okay, hey, this has been tested positive, this is not true, this is true. All those contexts, all those real-time memory or real-time insights needs to be passed between different agents that you orchestrate. That has to be facilitated. Hence you need to maintain a memory during the execution. So that is very essential, and it needs to be passed in the memory, maintained memory. So there are two types of memory. One is short term and long term. This, like what I'm talking about, is a short term memory. This is valid during the execution. Sometimes after the execution, the whole analysis summary, if you want to pass it on as a context, like for the next time, so you need to preserve this memory for the long term. So that's a separate context. Let's not even go there right now. So this memory is essential for your system to function for a given prompt, right? And then orchestration. So how do you stitch different agents, different components? Okay, so there is one side customer, there is another side like region, there is another side like with the payments, the other side, okay, do I have enough stock, inventory control, and and then there is your supply. Okay, uh, typically it takes 3 days to deliver. Now because of some monsoon and logistics issue, my delivery timeline is 10 days, and then people are not ordering, so that can be another reason. So there are different components solving the same problem, but having like solving for their individual vertical. How do you orchestrate the communication between all those things, like whether it is going to be a single master who invokes all these different nodes and then get the responses summarizes, or it has to be in individual system. How do you orchestrate the system? That is the other parameter, that other component that we need to be fully aware of before building the AI system. And there are multiple orchestrating frameworks. You have your lang chains, uh, you and there are so many frameworks available out there in market, like which lets you orchestrate it. And then evaluation. This is one of the key element. Like this is where the trust of the system comes. Whatever the number that you have given me, whatever the reason that you have given me, is it trustable or is it real? Like how closer it is to the output that a human would have done, right? So that builds in the trust. And the evaluation broadly is two-way. One is deterministic. So, okay, what is the total number of orders yesterday? That has to be, is it matching with what is there in the report? Yes, that is deterministic evaluation, like where you know the defined input and output. And the other is rubric, okay, whether, okay, this has been tested after this, or this is the flow of thoughts and all those things. So all these things put together defines an AI system. Yeah. So this is where I said, like, okay, what are the tools? Like there is a SQL tool, there is search, API, calculator, internal system. Sometimes your competitor pricing, you can write a different tool for that, and then like agent queries the tool. What is the pricing for the same product with the competitors, or how is the pricing changed from like the previous days in your own platform? It can be any of those, right? And then there's the orchestration layer, like how do I orchestrate? So I will generate the analysis plan, I will query each of those components separately, and then I synthesize the root causes, right? And this is the trusting layer, accuracy of the result, and whether the results or like all the facts can be traced to the evidence. Okay, if I say the order is dropping because of logistics issue, is there an evidence which shows there is a logistic issue? Okay, yes, typically the undelivered orders or like unkept promises is X%. Now it has increased to Y% in the last 1 week, and that actually supports the claim. So whether there is any grounding, and tool correctness, whether it has hit the right sources and gives you the right answer, and like did it invoke the right API and all those things. And reasoning flow, this is where the rubrics play a key role. And then consistency, like no matter how many times I ask the same question, do I get the same result, right? And failure behavior, this is another important thing. When a particular data is missing, typically AI generates a generic response. Okay, are we handling that? Okay, no, you should not assume things. You should really answer if you have the data. If you don't have the data, just feel free to call it out. No, I don't have access to that. That way, this makes the system to be more trustable. Yeah. So in the build with AI, I would like to reiterate, AI does not eliminate the structured thinking. It just makes the structured thinking more valuable. So how clear you are with respect to your end system, okay, is much more valuable, and it gives you a much better system uh, what you are even uh, than like in the non-AI world, right? Like because things can go wrong at any point in time if you don't define it properly. So our structured thinking is always relevant no matter what era that we are living in, right? With that, I would like to take you guys through one of the system that I built for this exercise, right? And also it's a win-win situation for me. Like I give it to my nephew as well. Uh, he sits in Bangalore, right? So the core objective is you want to learn Python, okay? And I know he's very fond of building a home garden kind of a thing. Like I know his interest lies in towards that. So what I did is I sat with the AI rather than asking for a generic learning material. What I did is I I asked it to give me a learning plan, but it has to be broken into a smaller snippets. Okay, obviously the attention span now versus earlier, it has drastically reduced. So I cannot have like too big a section. So it has to be broken down into multiple smaller section. And I want to create a farm kind of a thing which he would build. As and when he completes each section, a tree or like a bunch of plants grows in a particular sector. And I also have created visit the farm kind of a thing. So he has to periodically visit the farm, how the health of the farm is looking like, and it has to be Instagram shareable, and he can download it as a image as well. All these things are defined customly by me for my nephew. So I have defined each and every module, like, okay, what it should contain, what it should not, how the grading should happen, what kind of questions that it should provide, and if I can sow some of the questions from the popular coding platforms that is out there, say HackerRank and all those things. So get the coding relevant questions from the HackerRank related to the module and put it here and evaluate. Mix it up with easy, medium, and hard problems, and based on which the health of the tree is determined. That's how I have defined it. And he can take a periodical look of how the farm is growing. And I want to make it to be consistent as well. I don't want him to uh, say take few sessions today and then like leave it for a week uh, and then like resume it after a week and all those things. By that, the plants doesn't grow that way. So I have ensured that he visits the farm every day, else the farm dies. So I have defined a stake. These are the nuances that we define to make the system. And whether the system is working properly, I've taken the test myself, ensured the grading is done properly, whether the questions are from HackerRank, and whether those are relevant questions to this particular section, or are there any questions which lies outside of the current scope that has been discussed so far. All those codings I have done. And once I have done all the guardrails and I have defined, it took me about 45 minutes to 1 hour to define the end-to-end system, like how I want, what I want, and all those things. And once I have done that, I have asked the AI to develop the individual components, and then like what I got is the final wonderful application that you guys are seeing it in the screen. And moving towards working with AI, I think this will be a more interesting and like more anxious section that we all have in the current world. Okay. So working with AI has a different mindset, I would say, rather than the skill. Skill we all possess. And writing AI applications is not complex, trust me. Having written algorithms, having written tons and tons of codes in the past, writing AI orchestration and all those things is very simple. Then what is stopping from everyone to adopt and like using it is the fear, right? Like what happens if we build it? Will we be replaced eventually? The answer is no. I know everybody says this, like every AI practitioner says this, like that AI will not replace us, but uh, the fear exists with larger proportion of people, right? Like whether AI will replace. I have a solid fundamentals which explains why AI will not replace humans. It, in fact, it complements and we can achieve more. Yeah. So until 20, 30 years back, before the widespread usage of computers in place, all our all the previous generations, the way of their working is they solved a problem. See, be it your FMCG industry or be it your uh, real estate industry and all those things. Okay, I need a place to live. I'm going to construct a house. Okay, so they solved a particular use case. Okay, It was never meant about execution. Okay, you see how fast I build, how slow I build. It was not just that. It was like, okay, how well I am able to build a house so that like people can reside in. How well I am able to build a product which people can consume and which people can use it for longer. Okay, so how well I am able to grind a particular uh, type of millet or cereal and whatnot, right? So we have been solving problems, but last 20 years, I think like most of our employment has been into execution. Okay, how will I write the code? So the judging parameters were like mostly into the evaluation. Now with AI coming into execution, that gets rebalanced. So now we get back to focus on our core problem solving skills. Okay, how do I solve this problem of the customer, right? The consumer demand is never ending. It just transforms one from one need to the other need, but the need factor, the demand factor never ends. It never dries up, right? If the demand never dries up, the supply will also never dries. So in fact, AI will human plus AI is the combination that's gonna be wide prevalent in the future. It's neither either of them alone, right? It's not human alone, it's not AI alone, it's human plus AI, right? Right? There can be like two broader questions, right? The question one, how many people do I need to produce the same output? And question two, what can one person now build that previously needed a whole team, right? There is an emerging concept called as build report that I would like to bring it to your notice, right? So where like earlier there were about 10 folks for marketing or 10 folks for designing the search or 10 folks for something, any particular thing. Okay. Uh, let's say marketing, a CRM guy, one guy would essentially take care of the messaging part alone. He doesn't do anything else. The other guy would take care of who are the relevant customers. And the third guy would take care of the execution, right? Okay. Which platforms I leverage and how do I mass trigger the communications. There can be multiple people taking care of different aspects of the same function. Now, marketing becomes a single use case. Okay, identifying relevant customers is a separate module. Executing executing the campaign is a different module. So historically, people were not happy in doing the same stuff again and again. That limited their career growth and all those things, or variety, which we all need beyond a point. So imagine a guy doing the same old customer targeting like for 5 years, 6 years, right? Like by seventh year, he will be bored with, okay, hey, it's the same thing, same formula, but in a new environment. He switches company and then like he does the same kind of work, right? Now, what a practitioner would get to do is, okay, I get to define each and every part of the system, okay, how they interact with each other. Given this context, okay, hey, this particular customer cohort is not activated properly. For them, what are the blockers? Okay, I execute a separate set of agents. I understand the problems. The problems for a particular customer group changes with time. And how do I evolve the marketing strategies differently? So now the same set of three folks will get to decide on different customer cohorts, like how can they identify different sets of problems, how they can execute the marketing communication differently. Earlier they never had time to do the strategy works because the operational work consumed their lot of time, right? So yeah, this is like the yesterday's system and tomorrow's system, like how it would look. So there'll be a requirement, you'll write a code, you'll test, and you'll ship the code. And in the future world, with the AI blended world, you will understand the problem, decompose it into various components, right? Like how do you design the system, and then which portion are executable through AI, which are like coded, which are ML, differentiating those, and then evaluating all the outputs and owning the outcome, including whatever the AI generates. So that's pretty much in the working with AI kind of a environment, how it will look like, right? Now coming back to the relevancy in the job market pool, right? So who would you generally hire, like in the past, right? Like how, what it means for you guys. So that's why I took a moment and I would like to recalibrate like what is expected out of the students. In the past, all these kind of keywords caught everyone's attraction. While the keywords is still a point of attraction for the recruiters, I'm not denying it. But what gives you guys more credibility is how you have, how I read, by reading your resume, how I'm getting confident that okay, you have actually done a particular work, how you have executed a system. That's where the line of distinction now it's getting transformed into. Python, Java, SQL, machine learning, all these things knowing is great. Now AI can do this. So how did you leverage these tools and build a system? That is where like you will be calibrated on in the future. So I have built a diagnostic system for XYZ reasons. I've used these data and these set of tools for translating this problem and understanding the core reasons. Okay, I've leveraged several systems to create this particular module. So that is the implementation uh, n- knowledge that is getting exhibited in your resume would be more valuable than your executional skills going forward. While those executional skills are non-negotiable because you also need to validate whatever code that AI has written is essential. Now the expectation has gone far and beyond this executional skills, right? Right. And yeah, one thing, right? So I also did like a primary scan and I also researched with a lot of people, right? Uh, does AI replace humans? I know the answer is no, but I also need to be factual, else it doesn't fly with you guys. So what I did is I at least like interacted with 4 5 different people from different industries across different job roles, right? What I got to know is since system design and architecture design is an important parameter, right? And also the knowledge of coding is essential because it needs to be validated. If we don't hire people of current generation, we will be running scarce on people who can architect the systems in 3 to 4 years timeline. So there is no drought that is seen in the near term, right? It's just getting transformed. People who panic are the people like who probably not having a clear visibility on how the future would look like. But people who knows how it is looking like, how to embrace the technology. The technology never stops. It just evolves, right? And human has to evolve with the technology, and there is no second thought about it, right? As long as we do that, we embrace AI and we use it to our fuller extent, we don't have to really worry about. I just did a another quick scraping exercise today. I just mined LinkedIn, Naukri, and Hirist for the all the fresher job openings across different job families. There are about 85K Naukri openings and 3.9K LinkedIn openings and Hirist. I probably I didn't do a proper job in Hirist. I might have to revisit it. I just got 51, and that has been categorized into different sectors and different companies, like how many openings do they have, and like so what are the premium employers? There are about 4,000 opportunities from premium employers, and in which sector they belong to. 35.7 in software engineering, cyber security, and all those things. This is a simple scraping exercise that I did, right? And I also mind each of those job description. What are they asking for in the current scheme of things? Like what are some of the AI capabilities to be built if you want to become an analyst, and what are some of the AI capabilities that you want to build if you were to become a SDE from the job descriptions mentioned in those 4,000 odd opportunities that is listed, right? So all this is possible, and imagine like the time it takes for me to do it, like it is less than 20 30 minutes, right? So the information availability is plenty, and The opportunities are plenty, just that it is getting transformed. You might see some of the teething issues during the course of transformation, but eventually settles down. The supply has to be there to meet the demand, and the demand never evaporates. That's all I wanted to cover in this particular section. And one philosophy with that, I just end summarize all the three uh, pillars of the AI systems. So think, build, work, think, define, and what how a system is looking like, and decide on your evaluation parameters. In the build, architect this system, and AI will execute it, verify each and every output, whether it is working as expected and it is consistent, and then work. So working with AI is like you understand the entire system and then own the responsibility end to end, right from the user understanding or system and system understanding to the results delivered. You own the outcome. With that, I would like to end the session and open the forum for any Q&A.
Yes, sir. Sure, sir.
Any questions, Prasad?
Yes, sir. So, it's just from my side, sir.
Yeah.
In next 3 to 5 years, where AI skills do you believe will be the most important for fresh graduates when they are entering the industries?
Okay. So the core competencies like in the AI world for say it varies from one job family to other family. So the first and foremost thing is understanding the fundamentals of AI, that is more essential. So how it works, right? And the limitations of AI, right? Um, I think for the freshers, like it is better like if they start building some of the systems and start posting things in GitHub in their GitHub profile. There are plenty of GitHub repositories where we have the predefined use cases. Let's say I can probably share one GitHub link where they have 500 AI use cases listed in their thing. Like those are very small use cases that can be a starting point and then can be used to leverage. In the next 3 to 5 years, uh, so how can people define or structure the system? The system design is a core fundamental. And how do you system design with AI? That is an evolving, what do you say, field of study. So if people could master both, that would be super helpful. And AI, absolutely, AI components is a primary thing that people should understand.
Okay, sir. Thank you, sir. And in YouTube, we have some of questions.
Yeah.
How do we build sustainable AI practices when the technology is a moving target?
Okay. It's a very good question. So the technology changes like every 2 months, as I said. Like so, for example, we started building that reasoning system uh, like about 6 months back, and now like there are certain things like which are outdated, right? So we had to change. But what doesn't change is the fundamentals, right? What you need, like how you need. Only the execution uh, methodology changes, right? But not your requirements, not your guardrails, nothing changes. Your harness remains as is, right? So the tools will keep on evolving, okay? As long as it is a plug and play, we need not worry about it. And how do you know like what is the right and like what are the known gaps like in the current system that you have built? So that is the space where you need to continuously monitor. Say, for example, when we started building the system, the observability hasn't evolved to the extent that it has evolved. So it has now come to the place where we need to change the entire what is a log monitoring system, right? But since that has been built as a separate component, it didn't affect any of our individual things. So we knew that the consistent results was a problem when we built it, right? Like every time a question was asked, uh, 80% the answers overlap, the 20% was a different thing. So we control that using system prompt, like so okay, we ask certain questions. Okay, did you pull this print trick from this particular place and all those things? Did you invoke this agent after this agent, like for this kind of use cases? Those are like a lot of context that we had to give. Now, when there is a proper observability metrics that, and also the proper infrastructure that came into the place, we gave that task of transforming the pre architecture to the current architecture using the AI itself, and then like we now transform. So knowing the limitations and knowing the design architecture would actually help you be prepared for the all the changes. And you need not worry about all, you need not be very reactive to all the changes. Sometimes it is okay to be outdated, like for some amount of time. You need not change, you need not be reactive every time. But if it is a tectonic shift that has happened in the technology, yes, you need to change.
Thank you, sir. And one more question. Do you think AI will primarily replace jobs, transform jobs, or create entirely new categories of jobs? What should students do today to prepare for that transition?
Yeah, it does not replace it. The part of the second and third is true. It transforms the job, and also it creates new stream of jobs. So the job transformation happens in, like say for developers, earlier they were evaluated on how to write efficient algorithms. That is now done by AI. How do you structure it differently? How do you design the system? And for analysts, writing efficient queries or building great Tableau dashboards or like doesn't matter anymore. They have to build decision frameworks, decision intelligence. Okay, should I give coupon or not? Should I give coupon to this customer or not? Right? Or should I onboard this particular inventory or not? Like it's more like on deciding decision frameworks. That's how an analyst role is getting transformed into. It's definitely transformation. And the new roles is coming in terms of some of the new areas. I have slightly limited understanding on the new areas, say that is like evolving in terms of robotics as well as the quantum computing, that those are the new spaces that continuously evolve. Right now my understanding on those things are limited, but it is definitely, it will be in those spaces as well, right? As we move towards AGI and all those things, obviously it will transform a lot in the future. How do we, how can we be prepared is, uh, first, acceptance is the key. Just to give an example, um, I have always been very passionate about analytics, the way the analysis is done. Like, in fact, like I've deferred like so many opportunities in the past just to work in an environment which gives me enough challenges and all those things, right? So from 2011 to 2025, that has been my forte. And 2025, when AI does what I used to do, okay, I was not feeling insecure. I just transformed into, okay, how I can build decision framework systems. That is the transformation that I did. So accept, yes, that it is going to change, and acceptance is the key. And second thing is be ready to transform all the new technologies. Always in the human evolution, it has happened. Like when the industrial revolution happened sometime 30, 40 years back, that was the change. It never took away the job. So how can you be prepared is getting regular updates. Okay, set up the all your cloud environments or chat GPT environments, monitor all the feeds. And you guys have Reddits, you guys have Discord communities, monitor all those feeds. And there are some AI forums as well. I will be happy to share those things. Get the regular updates, be updated, and then challenge your own knowledge every year, every 6 months. You should question your own knowledge on the latest trends and technology. That's how you can be relevant at any point in time.
Okay, thank you. So, one last question. Beyond prompt engineering, what are the most important skills students should develop?
Okay, architecture. So like developing multi-agent architecture is a key skill that you need to develop, right? And then observability. These are the two primary fundamentals that we need to learn now, or it is already late.
Thank you, sir. So, thank you so much, sir, Mr. Nachiappan, sir, for the truly insight and inspiring session. So we are certain that every participant today has walked away with a valuable knowledge and a fresh perspective on artificial intelligence. I once again take this opportunity to sincerely thank our RMK group of institutions management for their visionary support in creating such meaningful platforms of learning, our respected principal for the constant encouragement and leadership that inspires us all. All our heads of departments for their wholehearted support and coordination. I special thanks Dr. R. Rajaguru, Department of Computer Science and Engineering for the gracious and continuous encouragement. Thank you all once again. Thank you, sir.
Thank you.
Nachiappan sir, thank you, sir. Thank you very much for your valuable session, sir. I think so. Our students will learn a lot, and our students posted a question that has been asked by our professors. So, thank you, sir. It is one of the learning sessions. Thank you, sir.
Thank you so much. Thank you so much.
Thank you, sir.
Thank you all.
Sir, Regin, sir.
Yes, sir.
Sir, session has ended, sir. You can.
Fine, fine.
Rajin sir, thank you, sir. Prasad sir, thanks for coordination.
Thank you, sir.
all.
Regin, sir. Thank you.